Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had 30 different franchisees I worked with, as well as the shops that they serviced, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic at hand is guided component testing. Simplify your diagnostics. Now, if you haven't used guided component testing before, and I hope maybe you have, but maybe you haven't, and that's okay. You still might think, well, to test components nowadays, I really need to use a scope. And that's pretty much true. To a lot of these high-speed signals now, we need a scope for a lot of these things on a vehicle. And, we have two different types of diagnostic tools that are out there. We have our scanners, which I like to think of as a really nice compass. Going to point you in the right direction. It's going to show us where you need to go, where you need to look. But it's really only part of what's going on. It's really the effect after it already happens. Scopes are there to pinpoint the cause. So I'm going to actually go and test the component or test the wiring. Something I'm going to be testing directly, not relying on that scanner data. Because if we think about a computer, you may have seen this before, but if we think about a vehicle's computer, it's like a house. It's got a front door, it's got a back door. Coming in the front door is going to be all my raw data inputs. So it's all my coolant temp sensor, NOx sensor, oxygen sensor, all that stuff going in. And then coming out the back is going to be all my scanner stuff, right? My process data. So the computer takes in all that raw data input, processes it however it's programmed to do that. And that's only as good as its programming, right? And then it sends the data out back to the scanner. So if I'm only using a scanner and I'm not testing the signals before it gets here, or I'm not testing the data, the raw data before it gets to the computer, then it could be skewed by the computer. A good friend of mine used to say, "It's a scanner doesn't lie, it gets lied to." All right, so once again, only as good as the data that's coming out of the car. And if we want to look at a comparison, we get the top of the screen is going to be oxygen sensor voltage coming out data stream, right? So I'm hooked up with the scanner at this point. And then at the bottom is going to be my scope, and it's going to be hooked up to the same oxygen sensor, reading the same data at the same time, the same voltage. But these two red boxes show the same amount of time passed. And I think you agree, those two patterns look pretty different. There's way more detail in that scope pattern versus the pattern that you would get just looking at scanner data. Scanner data is only, it's not truly live data. A lot of folks call it live data. It's not truly live. It's at least that few milliseconds. And once again, it's the computer's interpretation. So it brings the data in, processes it, sends it to the computer. Brings the data in, processes it, sends it out, in and out, in and out. Every time it processes, we lose a little bit of that resolution in the data. That's why we need to use a scope in order to test the signals so we can see, oh, are these two little tiny millisecond, microsecond dropouts going to affect my drivability? And absolutely it can. So when we're testing components for failure, which is really what it boils down to here, it really falls into these three buckets, I think. There could be some outliers there, I guess, but by and large, it's going to be falling in these three buckets. So we have an open, we have a short, or we have a resistance issue. So open is going to be either I have no voltage to the component, maybe it's a 5-volt reference that supplies power, and I don't have that, so component's not going to turn on, it's not going to work, or it has low voltage, could be not working properly. Or no voltage from the component. Maybe I'm getting the 5 volts and maybe the ground is good, but the signal wire that comes back to the computer, the signal's not making it back, right? So maybe I have an open in that case. And then we have a short. So we could have a short to power, so excess voltage, so 5 volt and a 12 volt line rub next to each other, and now we have 9 or 10 volts going to a component. That's not good. Or insufficient voltage, shorted to ground. Every time that harness rubs on the ground, it pulls a little bit of that juice away, so we have less. So it's a not enough voltage or too much voltage, short. And then resistance could be corrosion, especially up where I'm at. You know, they put a bunch of garbage on the road in the winter to keep the snow from sticking, but also highly corrodes wires and anything metal, really, or damage, right? So we get that frayed wiring harness, and that could increase the amount of resistance in the wire. You know, I've got a multi-strand wire, maybe a couple of those strands are broken, but I still have a couple that are still good. I might get a good reading, but it's still a resistance issue. It's not going to carry sufficient current. So what is a lab scope anyways? If I'm going to use a lab scope to test stuff, as we say that we should, and we recommend that we should, I'm going to use a scope to test components. What is it? Well, I like to think of a scope as it's a window. It's going to show a measurement of some sort over a period of time. So I can see what is that signal actively doing at this time, voltage, pressure, current, whatever it happens to be over a set period of time, whatever I decide that to be. Now, if I'm using just a scope, just a plain old scope, I need to know some stuff. If I'm going to test a part using a scope, I need to know ahead of time going in. Well, first off, where's that component I'm even going to test? Where is it? Is it like stuffed under the engine? Is it on the firewall? Where is it? How does the component work? Is it a solenoid? Is it a thermistor? Is it a potentiometer? What kind of work does it do, and what kind of signal should I be seeing when I hook up? How about the wiring pinout? Where am I going to connect the power? Where am I going to connect the ground? Where's the signal wire? I need to know all of that going in. How am I going to test this? Am I going to test it using voltage? Am I going to test it using current? Am I going to test it measuring resistance? Am I going to test it measuring pressure? Depends on, of course, what that component is. But if we think about a fuel injector, for example, which we're going to talk about here in a bit, I can test all 4 of those things on a single fuel injector to see how it's working. What range do I need? Voltage range, current range. You know, does it need to be 10 volts, 50 volts? What does it need to be? What is the best tool for my signal? Because there are multiple ways of measuring that signal out there. So do I need a DVOM? You know, it's not terribly fast, but maybe it's just a signal that I need, like a resistance. Graphing digital voltometer, to take that and graph plot that DVOM stuff over time, or a scope, you know, my highest speed capture device that I could have. Or do I need an ignition scope if I'm working on ignition? And also, what is good? If I'm going to test a part, do I know it's bad? Do I know it's good? I don't know what bad is unless I know what good is. Right? So if it's not operating within good parameters, then I don't know if it's bad. So that's an awful lot of information I need to know. And, you know, back in the day, we used to look at binders and binders full of information, but sometimes that can go out of date, and sometimes it needs correcting, and sometimes it's hard to find. So what does guided component testing do for us as far as a scope is concerned? Well, it gives us operation, it gives us location, it gives us connector views, it gives us wiring, it gives us tech notes, and it gives us between 1 and 6 different testing methods in order to test said component on a vehicle. It goes all the way back to 1981. There's over 7 million tests inside this guided component test. So really, that's what's going to help you simplify it. By testing the components, it's going to help avoid unnecessary parts replacement. You know, we hate replacing parts that aren't broken. Helps prevent comebacks in that way, right? So hopefully I can verify the problem and fix it right the first time so the car doesn't come back. Can also prevent the loss of a customer. So say I don't fix it right the first time. And what's worse than a comeback? It's a never comeback. They go down the street and they never come back and say, hey, you didn't get it right. Maybe the other shop gets it right. Then you lose a customer. Helps attract new customers. The other side of that coin could be, hey, you're the shop in town and now you have this reputation of fixing it right the first time, and that can help attract new customers. And no matter where you work in a shop, from the secretary to the owner to the tech, having a profitable shop is just good for everybody all around. All right, good for everybody all around. All right. Also inside guided component testing, there's built-in training. Now, I'm here training you, of course, right? But inside the tool, if you have a scan tool, Snap-on scan tool, with guided component tests, I'm going to show you how to get to this in a second. But there is built-in training inside the tool. There's over 65 different categories of training in there, anything from 10-minute basic electronics, 15-minute air conditioning, and so on and so forth. This is just one of the screens. Like I said, 65 of these different categories, and then there's also sub classes underneath. For example, this one on adaptive cruise control. Here's how adaptive cruise control works on kind of in general. CAN bus transfers messages between the engine control module, brake control module, adaptive cruise control, and then it adapts to the distance of the car using radar. Also in guided component tests, like I said, it's going to show us how to hook it up, where to hook it up. It's going to show us the connector view. It's going to show us what each wire on that connector does. And then it even tells us what it should look like. If it's a signature test, we get a picture. Otherwise, maybe it's a voltage test and we get a voltage range, or a resistance test, we get a resistance range, something of that nature, but it's always going to tell you what it's supposed to be, what is good. And also recent addition to this too is we, instead of just telling you where the component is in a string of text, we're also going to show you where the component is. So this is on select cars now, and it will be going more and more. We'll be seeing this as we move forward. They just added a ton in the next update, but it gives you a generalized location, and then it shows you exactly where the part is. I think that was pretty slick. Right? There's an example. There's overall. Here it is on the left-hand side, and then the detail in the engine compartment itself with the ABS module. Also enhance the connector views to make them larger, because sometimes we notice on the smaller screens, these connector views have been around for a while. So we had some people come and draw up some more different wiring connectors right inside the tool. So let's go on the tool and let's talk about the different things that we might be doing and how guided component test is going to help us. All right, so let's take a look and see how would guided component test help. Now, guided component test is available on any tool that Snap-on makes with a scope. So, for example, Zeus Plus, Ferris, Verdict even came with one, right? Modus, Triton, any of those tools with a scope are going to have guided component. But before we go in there, let's talk about what information would I need if I didn't have guided component test. Now, if I didn't have guided component. So first off, let's say, I got a 2012 BMW, right? And let's say I think I have an injector problem, but I'm not sure if I have an injector problem. I need to gather information to figure out what's going on with it. So I'm going to hop into my repair information, and I'll just go back to my surgery here. I'll search for injector. All right, let's say we're replacing each. See what we got for TSBs. You should always check TSBs first, right? So this one doesn't necessarily apply to this particular engine on this car because this was direct injection, right? It's going to show you how you would do that. Real fixes, top repairs. How about specifications? I might want to ohm this out. Is there a specification in there? No, there is not. Okay. How about on OEM test procedures? So let's see. It gives me an idle speed control rationality diagnosis. It gives us a couple little things there. Time for idle speed and such. All right. Not a ton of information coming from BMW on this thing. All right. Let's go down to, let's just say we don't go into guided component testing, because that's what we're going to show you here in a minute. Same with the connector and location. Component operation, how's it work? It's going to walk me through that similar table there again, how it monitors it, how it calculates airflow values. Wiring diagrams. I'm definitely going to need wiring diagrams because I need to know where it's plugged in. So on page 3 of 4 of the wiring diagram, you can see I got my fuel injectors there. If I open that up, I'm going to highlight just one. So highlight them all. There we go. Highlight that one. All right. That's in. So we can see they all share a common power. It's orange. And then the individual control wires. So we got white, white, green, white, yellow, etc. Now, maybe I can't get to these fuel injectors. Maybe I can, maybe I can't. Where does this go? If I go across the page, it's going to come over here, and then I can also test it at the computer, right? So I got my input signals or my control signals there, right? Injectors 1, 2, 3, 4, 5, 6. All right, so we have all that information there. All right, so now I know where to test it. Do I know what good is? I don't think I do know what good is. But I can guess, maybe I have some experience in what it used to be. I'll tell you that I looked through here, all the information that BMW published, and I'm not seeing anything in here for like a resistance test or anything like that. It does tell you how to replace them though. There's the harness there. There's the fuel rail. There's what it would look like. There's a special tool to close off the pipe. And then there's the injector right there, clipped in there. And then it says clear the memory. So that's about all it tells you. It says replace them. Doesn't say much about testing them. Doesn't say much about what I need to do. Oh yeah, and if I want parts and labor, you can go into parts and labor. Fuel injector is going to be $222.90. Diagram here is number 2. All right, so $222.90. Hopefully that fixes the problem, right? And that's what a lot of people will default to. It's like, well, I think it's an injector problem. Let's roll the dice and replace the injector and hope that the car doesn't come back. And I hate doing that, especially on a $222 factory part. Could be less aftermarket, don't know. It's only 0.8 to change, or that's to clean it, I guess. But if I wanted to change it, it's like a couple hours, right? So having all that, I have some information, but I don't have all the information. So let's go in to my scope and see what I can do here. So I'm going to back up. So I'm going to go into my scope, and let's say I want to ohm this thing out. Well, I don't have option for ohms on this thing. Let's see. Let's go into, maybe my multimeter has the information. Oh yeah, there we go, ohms. All right, cool. And it says you want to calibrate it. Yep, so if we want to calibrate it, what we got to do is we're going to have to short channel 3 and 4 together. So you just take the little clippies and clip them together. Hit OK. And it's going to calibrate all the scales. All right, there we go. And I should have 0 ohms because, hey, I'm plugged together. I should have perfect continuity. Now, if I want to check this fuel injector, just going to kind of shake it out here. There we go. 11.24 ohms is what I'm getting. Now, is that good? Could be. Maybe. Maybe not. Right? So 11.24 ohms could be good. All right. We could also test voltage, right? So let's use our multimeter and test voltage. All right, so I'm hooked up at the fuel injector somewhere, and I'm seeing, actually I'm not. All right, there we go. So I'm getting 17 volts using my multimeter to test the fuel injector. Is that going to work? Is it good? I don't know. All right, maybe I don't want to use a meter. Maybe I want to use a graphic meter. All right, I'll do volts again. Hey, what's going on there? Going up and down a lot. Maybe that's not appropriate either. Maybe I need scope. Super scary scope. And I'm going to set it to volts. All right. I'm getting something. I can't really tell what it is, though. Looks like it kind of goes off the screen or something. Maybe I need to go down here. And maybe I need to change my volts a little bit. Maybe 100 volts. That's pretty good. That looks kind of tiny, though. Do I need to zoom? I can't really zoom. Oh, change my time. There we go. I'll change my time down to 10 milliseconds. There we go. There's a fuel injector. That looks like a fuel injector. All right, make a little adjustment here. All right. So hopefully I figured out where to connect. I did have a wiring diagram, so I can at least do that. And then once I figured out what I needed to do, once I figured out what I needed for whatever meter, once I figured out, how to change my voltage and my time and get everything kind of set up, I still might not be 100% certain that this is good. I mean, it's a simulator, and I know that's a rough approximation of a known good fuel injector. But if I didn't know that, I don't have this information at my fingertips, it's going to take me a lot longer to get to where I need to go. Now, with time, with experience, right, I can go in and I can say, yeah, I know I need to put this voltage here and I need this time here, and this is where I need to connect, and maybe I know what good and bad looks like at the time. But if I don't have that information and I don't have this past prior knowledge, kind of left out, right? Even especially from BMW right there, you can see there's not a ton of information. And I think that's a lot has to do with how BMW does their test plans and stuff like that. They don't necessarily have it published that way. So let's see what I can do with guided component test instead. So if I go into guided component test, I load into the vehicle, and then there are all my systems that I can test. There could be up to 12, depends on the vehicle. Fuel injectors live in the engine, so we're going to go there. And then we'll see a list of components or even subsystems, like the fuel system will go in there. And then we'll see a fuel injector. Let's learn about how this fuel injector works first. So we go into component information, and there we go. It's a conventional fuel injector. These are normally closed solenoids responsible for delivering atomized fuel to intake manifold ports. When energized, the coil winding inside the fuel injector create an electromagnetic field. This will pull the pintle off the seat and allow the injector to spray fuel. Injector on time is known as pulse width and is calculated by the ECM. It's going to tell us ignition positive is supplied by the fuel injector relay, and the PCM switch is the ground side. Good to know. Best place to test it is at the ECM itself, because the fuel injectors are mounted to the cylinder head in front of the intake manifold in the fuel rail. Might be difficult to get to. Here's where the supply voltage is, and here's what the connectors are. So right here on one screen, I don't need to look any of that up. I'm good. So now let's see if I need to test it. So let's start with that resistance test that I started with before. All right, so this says red to the injector control, blue to fuse 5. And then resistance at around 68 degrees, which is roughly, it's probably a little warmer in here, but should be about 12 ohms. Should be anywhere from 10 to 14. Due to inaccessibility of individual injector connectors, testing at the ECM may be required. And then we'll hit V meter. I already calibrated it, so I'll hit no. And then there we go, 11.24 ohms. It automatically pulls up the meter that I need. Not just a scope. This isn't just scope. This is meter, graphing meter, lab scope, ignition scope, whatever I need for this particular test on this particular component. So I didn't have to search around to try and find ohms because it's there. Now, if I back up and I wanted to do, say, a signature test, which is voltage, I can go in here, yellow to injector signal, black to ground. I have my connectors there with my connector wire colors. Hit view meter again, and there we go. There's my injector pattern. Now, notice it's a little clipped off of the top, and that's okay. It does say right here, as load changes, on time will change and may need to raise the voltage level if the signal is clipped. So the signal is clipped. So I can still come down here, and I can still pull up my voltage scale, and I can still set it to 100, just like I had it before. And that gives me that little extra room. I can also move this around using the trigger. Anything I can do in the scope, I can do in here. I can add channels. Let me make this a little bigger. I can come in here. I can see my measurements. I can come in here and I can add channels if I want. I can have up to 4 channels on a Zeus or a Varus, 2 channels on everything else pretty much. I can still change my scale like we saw before. I can change my time. Now maybe I want to bring it all the way out to 10 seconds. Okay, 10 milliseconds, 10 seconds. Big difference. But I can do all that within the guided component test meter, and I didn't have to look anything up because it's right there on the screen. Now, another nice thing about this is I have a known good, right? So we have, here's what good looks like. Here's what that looks like. Do they match, or are they really, really close? They are really, really close. So we can see that comparison on the screen. So I have all my wiring, my component location, where is everything on the car and such. If I wanted to do a pulse width test, I can just go in here. It's going to say snap throttle and release. Injector on time should increase and decrease at normal temp. Injector on time will be about 2.5 to 3.5 milliseconds. The throttle snap can reach 20 milliseconds. Hit view meter, and it's just going to give me a graph of my pulse width. Right. So if I rev it, it can go up, We can see that. And oh, by the way, this is a graphing meter on this portion. So I had a DVOM, I had a graphing meter, and I had a lab scope, and I didn't have to worry about leaving screens and moving around and changing menus and stuff. The tool just picks what I need for the job. And then current ramp test. I don't have a current probe hooked up, and it actually wouldn't work on the simulator anyways, but it does give me a nice known good pattern at the bottom of what the current ramp should look like for that vehicle as well. It tells you exactly where to hook it up and what to do. So I don't need to look anywhere else. I can just look on the tool and I can see, well, what do I need? What do I need to connect? How do I test this component without having to worry about finding the information on testing a component? Because I don't know how much harder it is nowadays to find information. That probably hasn't gotten a lot better, considering manufacturers decide they like to be secretive about some of this stuff. So having that information, and oh, by the way, these are done by real life people. I see one guy commenting on YouTube. I'll get to you here in a second, but he used to work for us and develop these tests. So yeah, so we know real life people do work on these tests. So they're developed by people, not just an algorithm or something like that. It's real people going to hook up to real cars, getting connector views, pinouts, location pictures at this time, and things like that, all at your fingertips, right on the tool. You don't have to know how to set anything up. And it just boggles my mind that I talk to people all the time and they're like, oh, I don't use that. I don't know why you wouldn't use that. How much time would that save versus going through and actually having to look everything up? Now I've taken the vehicle out so I can go back in here and just show you, right? So how many brands? 1, 2, 3, 4, 5, 10, 15, 20, 25, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 brands. 43 brands. 43 brands that covers. And it goes, like I said, all the way back to like 1981. So if I go into like a Cadillac, 81 Cadillac DeVille, right, with the 4-wall, we can look up stuff. Now, there's not a lot of stuff on the car, but we can see carburetor, barrel sensor, coolant temp sensor, ignition control module, oxygen sensors. I can look all that stuff up. I got to get out of the car again. All right, all that stuff's available. Like I said, goes back to 1981. Also, I'd like to note, we've moved this button around many, many times over the years. Finally, we've settled on it needs to be first. Training classes. Classes need to be first. So we'll go into classes, and then you see we have power user test, features, and how to. If I go into power user tests, you have a bunch of different current probe tests, dual channel tests, secondary ignition tests, pressure transducer tests. Going to walk you through how to hook up and how to do that. Those are kind of generalized, not vehicle specific tests. And then if I go into how to, that's where all the meat of the training is, right? So if I go in battery drain test class, electronic park assist class, 10-minute running compression waveform class. So if I wanted to hook up to a pressure transducer and see what it's supposed to look like with a running compression, 4-wheel steering, HID lights, let's see, pressure transducers, again, SCR, stop-start technology, TPMS, automotive electrics, CAN bus classes, right? I can go into CAN bus and I can learn all about different voltages and signal qualities and waveforms. All right, here's a couple different waveforms that you can use on the. So tons of information at your fingertips just to learn. And then when I hook up to a car, and the other nice thing about this is I don't have to be hooked up to a car. I can just do this on my own whenever I need to. I'm sitting down with the tool in my lap, and I can just kind of hook up to, let's say if I wanted to look up a 2018 GMC Savannah with a gas ethanol in 6-liter. I can go in here under engine, and there's all the different sensors. Cam sensor, for example, where is it? So it's, let's see, located front center of the engine below the water pump. There we go. So now I know. What about the crank sensor? What if I wanted to look at that? I can go in there, and crank sensor is going to be on in the engine compartment, left of center, near the rear, mounted to the lower left side of the engine. Perfect. And it tells me where my 5.0 reference is, low reference crank signal. These are just random examples that I can pull out of anywhere because I know the information's in there, and the information is, like I said, worked on by real human beings, right? So great to have. Wonderful way to speed up and simplify your diagnostic process. As we said, guided component tests will really help you with simplifying your diagnostic. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/SnapOnDiagnosticsUK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully, we'll see you next week. Hopefully, you can watch and see you on any of our other videos. Have a good week. Have a good night and take care.